The great review, as I was saying before, it's just so that you have a peace of mind about what we've covered in this class. I think it's important that you know where we've come, and that will give you some ideas about perhaps where you'd like to go, what you can put in your resume, what kinds of careers are out there, what kinds of things you can do with these skills that you now have. And believe me, you do have some really amazing skills. You do have some amazing skills. I know that when you first take a class and you think back to your you think back to all the things you've learned, you might ask yourself, is this really such a valuable skill? I would say that in today's day, with with all the data that we have and all the the online activity, all the data that's coming out of the online world, it all has to be stored somewhere. And so I'd say that the skills that you have are actually very, very effective at maybe finding better skills. These are some notable dates that are coming up, which we just discussed. Please take note of these. And by the way, I put the repository up here. I've seen that there's only like 3 or 4 people who've actually clicked on this repository link to actually establish your project. So please do click on that link and accept the assignment. So anyway, getting back to this class here, what kinds of things have we discovered in this class here? What have we actually done in this course? Well, we've discovered some theory, and we've gone through some methods, and we've basically been playing with modern database systems. For instance, we have SQL. We work with SQL3, but that doesn't mean that, for instance, just because we work with SQL3 that we have no access or no understanding of the Microsoft SQL variety or the Oracle SQL variety. Those flavors of SQL are actually very similar to SQLite. The language is the same, the theory and the kind of the fundamental usage of the databases are very similar. It's just that like the Microsoft SQL and the Oracle SQL varieties, those are just much more robust, and they allow multiple users at the same time to interact with the database. Whereas SQLite 3, one of the drawbacks was that it only allows one user to interact with the database. And when I say one user to interact with the database, that just means one person was able to actually save at a time. Whereas the other databases, they don't have that limitation. And so the actual training that we learn in SQL3, though, should be sufficient to allow you to pick up any SQL flavored database and run with it. You should be able to do all kinds of amazing work now with your SQL coding skill that you've acquired in this class through all your hard work. We also worked with a new database, another tool here called the DB browser, which you can try using if you'd like. I think this. I mean, I use this every now and then, but that doesn't mean that everyone else has to use it. But the DB browser, there was more of a kind of a visual-based system, I guess, if you want to think of it in that term. But it helps you to kind of like find your tables with a little bit more. As you're writing your queries, you can see your table attributes, and kind of it just helps you to write queries. We also work with NoSQL systems like Mongo, and Mongo was a different type of different kind of database. It's still a database, but it's a different kind of database in that it doesn't require structured data to come through as SQL did. So in SQL, we spent a lot of time working with writing the schemas and putting the tables together and making sure that the data actually had a place to go once it was laid into the database. Whereas with Mongo, we didn't do that. We didn't spend so much time worrying about the schema. And that's one of the selling points behind MongoDB. And that is that when data comes in, as it does when online, when it's largely unstructured, you may not know what it's going to look like. You may not know what kind of table to build. You just know that you have to save it. And so Mongo actually provided a very convenient way of just kind of like pulling in the data, and then Mongo would create the schema as it went. Whereas in SQL, we really had to have an idea about what that data looked like before we could actually store it someplace. Then we worked with this other database here called Neo4j, which was a graphical database. Now, they're all databases, and they all allow you to retrieve information and kind of find things by writing queries. But Neo4j was different from SQL and NoSQL. It's a type of a NoSQL system here, but it's different from Mongo and SQL. In that it's graphical. And what I mean by graphical is that, for instance, it allows you just to look at how the nodes come together for all of your entities that you have in your database, and to discover for yourself relationships which exist between those nodes. Now you're probably thinking, why is that important? Well, if you think back to how you've been writing queries in SQL and for Mongo, you actually had to know that the relationship actually did exist, or you had to know something about that relationship between two entities in order for you to write a query. And that's just the nature of the game. However, when you are working with Neo4j, you didn't necessarily need to know that a relationship existed. In other words, you could look at the graph and kind of get an idea that, oh, a relationship now exists between these 2 points here and here. And I can see that, for instance, in the example that we worked with, we were looking at different actors and directors and writers who were involved in certain movie productions. And so we were able to see how one actor was related to another through all kinds of means, like whether two actors were actually working on projects which were directed by the same director, or maybe one actor was working on a project and another actor was working on a different project, but they were both directed by, or they were both written by the same person and they had the same director. Who knows? But we were able to find those kinds of patterns or those kinds of relationships which existed. And while when we were working with movies, that was a kind of a trivial, thing to work with. I mean, it's kind of trivial to find about these movies. In the real world, you might be able to find out that if you had a database here, where using Neo4j, which was connected to some kind of big financial system, you might be able to find out that you have customers over here who are paying a premium for some service, but then they're also paying another kind of premium for another service, and then they're paying, and maybe they're doing something else, and maybe that's something you don't want to have in your business. Maybe you don't want customers to be paying 2 different premiums for your business because maybe you'll get into trouble, or maybe that's an oversight or something. And so by looking at the graph, you're able to make those discoveries without having to, first of all, to write some query to see whether it's there. So what I'm trying to say, though, is that all these databases that we've worked with, they all have very specific types of attractions and reasons for being. And I think that from SQL, Mongo, and Neo4j, I think that we really hit in this class some of the more popular and some of the more sophisticated databases, which are actually big attractions in industry and academia for skills. I mean, there's a lot of need for skill in these areas. And I think you'll find that later on as you start looking around at database. If you're looking at database types of jobs here, you'll find, for instance, that many of these skills, or many of these job offers will be asking for skills in Mongo, or skills in Neo4j, or skills in SQL, or equivalent types of systems. And there are other systems out here which are very similar to these systems that we've covered here, but I think that these ones now have given you what I call the underlying theory of all the databases, which, like all the database technologies out there. And so you can pick up any technology and run with it. Anyway, I get carried away on these whole things here. I don't want to spend so much time on these, but those are really the big softwares that we've gone through here. And I think that now you're perfectly equipped to deal with seemingly any other software that exists in databases. And that is because you can look at the software and now you have an idea about how you can use it for different types of applications. Anyway, we also spent some time talking about schemas. We talked about time in this class manipulating data. We were talking about like how do you populate databases here, which is actually a very big piece of databases. I know that's obvious now, populating a database, but believe it or not, when I was reading a book about databases just over the summertime, it just talks about queries. It wasn't talking about actually how do you set up a database, how do you actually create the database. It talks about the schema, and it talks about some of the other, the attributes that you have to worry about, and some of the constraints that have to go into the schema. But nowhere did it actually mention anywhere how do you actually put data into the database. And so I wanted to spend some time actually going through the populating databases with you, so that now you know. Excuse me. We also talked about programming some queries. We talked about management and automation, and by that, and I've got slides that hit all of these subjects here, but these are just like the global pieces. We talked about how do you actually write a Python program which is able to kind of use abstraction to work with a database. And the reason why we would talk about that is because when you have a database, databases nowadays, they're really, really big. They tend not to be actually managed by people, but more like they're managed by other machines or other pieces of software. And so you would have to write some kind of a program to allow a database to be handled by other software. And so this is now a skill that you have. You can now write a program in Python which allows you to work with a database in both Python, or sorry, in both Mongo and in SQL, which is actually quite exciting. Yeah, then we talked about like how to pull information and data from a database. That's more about queries here. Anyway, so we spent a lot of time here in the beginning of the class talking about what is the function of a database here. And the function of a database is really to connect relationships. So I can connect, or to find relationships, use relationships to connect data together, but it's basically connecting types of relationships between different rows of data in each table with different tables. And so you are really connecting data. And this is a very, very important skill to have, though, because you are continually finding new pieces of information here, which has to be connected in order for you to make some kind of business decision. Now, one of the big anecdotes that I had this whole class when I first started, when we all met up on the first week, I think it was, or maybe the second week, I was talking about my my crazy time when I was working in I had my internship in a company where I was working with their database, and this was just a nightmare. And I don't understand how and the people were clever who worked there. I'm not saying that they're not smart. They were very smart, but they just didn't know about databases. And so I had to make this a point to you, and that is that they had two different they had one giant database which they realized was slowing down. And so then they cut it in half, and they just expected each side of the database to be updated in some way. But the problem was, we ran into these problems where we had these, the database became inconsistent. The Wonder base, which was the first database that they had, and the Potter base, which was the other copy, soon kind of diverged into their own different databases. They weren't the same anymore. And so therefore it wasn't useful because the addresses were now different. Anyway, and the problem behind this whole thing here can really be summed up in this one big picture, and that is that when you have like a whole bunch of different databases that are all doing different things, it's actually very difficult to make sure that everyone is on the same page, as it were. It's difficult to create to have a system here where everything is updated. In this particular schematic, you'll see that we're working with 4 different databases, and none of them are really connected. And so that means that if sales and marketing and human resources wanted to be able to have the same information, they would have to find some group or something which would allow their 2 databases to somehow connect and copy things over. And that's going to be a nightmare. Nothing was centralized. And that's the problem here. Nothing was centralized here. And so what I'm saying is that when you're working with databases, having a centralized database where you're basically handling all of your accounting, finance, your human resources, sales, marketing, manufacturing, all that stuff in this case is all in one big system, so that you can write code, or you can write queries and things like that, and hit all those different databases at the same time. But also, as you're putting the data in, it's automatically being it's updating all the databases at the same time, and so all people who need to have that information get an updated view of what the data is. Then we talked about like specific types of information in tables, like how do you make sure that each table is kind of like more specific here. And so we just kind of like found out that we were talking about like you have tables in your database, like that this is called the instructor table, and you have tables that kind of cater to specific types of relationships. And so in the instructor table, we said that all information in this table really has to deal with the instructors. So here we have the instructors' IDs, we have their names, and we have their salary. And then we have different tables, which are the department table, which is like just like the department name, the building, and the budget. But we would discuss like how it's very, very important, though, to avoid some kind of redundancy here by having the same information in 2 different tables. Rather, it's important to have tables where everything is more or less kind of, everything is very specific in there. So that's easier to update and maintain. So SQL, let's talk about that for a second here. SQL is where we really cut our teeth in working with these tables and learning kind of like how to write queries and kind of learning how to insert and update and modify data. SQL, the version that we worked with was version 3. There are different versions here, but if anyone asks you, it was version 3. And so I know. But specifically, though, we were able to kind of like, getting back to our relationships here, we were able to use SQL to kind of to work with these relationships. And so this is actually a graph. This is what they call a graph, but it's a tree graph of a database where you have, for instance, the relationship between the employees and the department, where employees work in a department, And each of these bubbles or these nodes, these round nodes that comes out of each of these tables, the square things are the tables, and the round nodes are the attributes. But each of these attributes is actually kind of a centralized piece of information to that table. So employees, you have name, SS number, the social security number perhaps, and the lot, maybe that's where they park, for instance, or maybe where they work. But that is information that concerns only the employees. And the department table, you see discipline, building, and status. These are pieces of information which concern the department. And so as you're putting together a database, you want to make sure that you're not putting discipline data from the department into the employees table here, because then it's just like your data becomes redundant. That means you have to, if you make any updates, you have to update the department table, which has discipline, and then you also have to update the employees table, which also has discipline. It's better to actually link these two tables with this works in relationship, so that if you do a query where you want to find out about the discipline of where the department where the employee works, you just link that information together in your query, and we discussed all that. You can see how, for instance, getting to these other types of links, this is a bigger database that we worked with, not for very, very long, but we did work with it. This is the Chinooks database, which actually comes out of the SQLite tutorial, where you can see how each of these tables has been created here. Genres, media types, tracks, playlist tracks, playlists, invoices, customers. All of the attributes which are in each of these tables is extremely specific, and you shouldn't find any repetition, because that would serve no purpose. As long as you can move from one table to the other without picking up your finger, if you put your finger down on one table, you should be able to go to any other table in this whole diagram without ever lifting your table. If you can do that, that means that you can make links between one table and the next, and that means you can avoid having to use any kind of redundancy. You can just go ahead and say, well, give me the piece of information from this table, and then show me the related information from another table, and then put everything together and show it to me as an output to my query. Anyway, but you can see though that these databases do get complicated, and so you do want to make sure that all tables have information which is specifically about that table, rather than having it scattered all over the database. We talked about entity sets here. Entity sets are, I'll just read this, a collection of entities of the same kind. They're kind of like all of the information which is somehow related to each other. And so this is a very basic table that we worked with. It's still a working table though from your database. The ID, the T, and the sandwich, these are all different entities which are related in some way here. They're related in this sense from the ID. So JJ, for instance, had T, and she had a Reuben sandwich. Let's see, we have OBC. I had a T, and I had a PBJ sandwich, and then there's AM. We had a tea and a chicken sandwich. So really, these are all each row here is an entity set which is related in the sense of what that ID drank and what they had as a sandwich. So then we talked about keys, and so we're talking about tables here. One of the more important pieces is to talk about keys. This is going to be a question which is probably going to come up in seemingly any interview when you're talking about if you're applying for a database position or a database admin, and they'll ask you, what is a primary key? How does that differ from, say, a foreign key? And foreign keys are in here somewhere, but primary keys, what are primary keys? Well, we remember they are the unique identifiers for a row. So for instance, in this case, in this table over here, this is not a perfect table because you have JJ and OBC and AM. Actually, JJ shows up twice. Actually 4 times. It shows up 4 times, and so therefore this ID is not going to pass the primary key inspector. It's not going to the primary key inspection's seal of approval here or whatever. What I'm saying is it's not a primary key. A primary key would say that nothing in the ID column can ever repeat, and so these are unique identifiers, so that you can keep track of each row. Even though you may have repetition, each row is actually unique, and a primary key makes sure that happens. You have some other kinds of keys that we worked with too, but I would say that they're all types of extensions where you're just keeping things unique. There are all kinds of systems where you're just keeping information in a table unique. And this is important, for instance, when you're working with primary keys, because if you wanted to link these tables together, for instance, the department, the T, and the session here, you have to make sure that if I wanted to do a query where I wanted to find out what person of a department and find out what that person's session was, and find out what that person has as T, whether they had a sandwich or they had tea. If I wanted to connect all these tables together, in other words, I would have to I'd have to enforce some relationship. And so the relationship that we enforce is done by primary keys, where we say that all the IDs are unique. And every time you find the ID JJ or OBC or AM or GK or PL, any of those IDs only occur once in each table, and you can use them. You can use those IDs to connect the tables together. And so that's really why we worry about these keys. And so they might ask you, for instance, if you took a test on database admin, they might say, here's your table, ID, department, room number. Argue for one of the columns to be turned into a primary key and say why that would be necessary. And you might say that, well, as I'm looking at this table in department, I see that the depth, DEPT column, I see there's a lot of repetition. People either work in CS or Geo, and so that wouldn't be good for a primary key. The room numbers would be okay, but after a while you might find that some of the rooms might repeat because you may have two people in the same room. But that could also be a good primary key in this data. But I'd say with the ID JJOBC, those names are unique enough so that even if the room numbers change, the IDs won't. And so you can maybe your database has a working primary key just in this data. Anyway, that's just one of the questions they may ask you. Then we talked about, for instance, just some tricks here, like how do you put data into a CSV format. Remember that we used these comma separated variable, or because these are the comma separated values saving function in LibreOffice, which allowed us to create these CSV files, which we then imported into our code that made our databases. That's actually a skill that I was looking for some time ago when I was first learning databases. Like, how do you actually get data into a database? But actually creating CSV files from spreadsheets using using LibreOffice, or I guess you can even use Excel. But actually to create these files and then import those into a database is actually something that I never really found much information about when I was actually starting up with learning databases. But now you have this, and so now you can use this skill. You don't have to use LibreOffice. You can use simply whatever you want. But if you can find a way of creating CSV data from other types of data, you now know that you can just import that into your builder file. And so we actually created files. We actually took this data here, converted it into a CSV file from a spreadsheet, and then we imported that into our database. We talked about selecting in SQL, where this is actually probably one of the more important pieces of your whole query is about just selecting things. I think that selecting is actually, when I see like the word select, it's actually kind of misleading, because in SQL, select is almost synonymous with your print statement. It's when I find, like, if you're just selecting something, am I just selecting it, or is that a print statement at the same time? And so it does, it selects things, but it's to print things out. And so that's actually quite important. I'm just looking at my notes here. Okay, so anyway, we also talked about, for instance, like how you can use select. We talked about like different types of manners of grabbing information in tables. So, for instance, if we just we use wildcards, which is that star. We were actually able to select certain types of columns. We were able to select wildcards and specific types of and have constraints, if you will. We were able to. I mean, our queries actually were built out of using these select statements here. We were also able to add other types of constraints where we were able to order the output that came from our queries. But this is just kind of an overview of like what these select statements look like. Then we talked about integrity constraints. These are basically pieces of code that you would add into your database to protect it from being, I hate to use the word mutated. It sounds kind of like some kind of mutation. But people are using your database, and people are entering information into your database. And so we used integrity constraints to ensure that people would only add numbers where numbers were required, or only add text where text was required. And that would prevent certain types of problems from happening when data was actually being placed into a database. But also that we had other kinds of constraints, like, for instance, unique or not null, or we had foreign keys in there too. And these were all constraints that we used to help us to make the database more useful or to add value to it. And the idea is that if you have, for instance, if someone's adding information into your database, but they perhaps forget to add the first name of the person, or the ID, or whatever is the name of the person that this row of data refers to, then that's useless data. You just have information, but you don't have any name, or you don't have any primary key, for instance, about where that information comes from. And so that is not helpful data to you. And so you would put a constraint into your database so that unless the name is there, you're not interested. You're really just saying that unless this data has been, or unless the row has a name, then don't save it. That's because that's the most important piece of information that there is. And so these were called integrity constraints, where you're actually kind of nudging the user in some way about how to actually complete the database for you. We also talked about in SQL the one-to-many, many-to-one relationships, where, for instance, one hand has many fingers. And you would do that because when you are actually arranging a schema of your database, when actually putting the schema together, you have to, for the sake of some of your queries, you have to be able to tell the database, or you have to be able to make the relationship between the tables here, where you can say that one thing in the table has many different other pieces which are connected in other tables. And this is all in our discussion of, like, the foreign keys. So in this example here, we have a supplier on the bottom of the slide. We have a supplier who sells parts, and the parts have line items, and the line items have orders. But you can see, though, that the supplier is one entity, and the supplier sells many different types of parts. I mean, think of any hardware store, for instance, or any store at all. You go inside in the store, you'll see that they have many different things to sell. And so one supplier, many different things to sell. So the reason why we put all this together, though, is because we needed to create some kind of a system of, kind of an established system of connecting the information, or making the information related to each other. And so when we established that the supplier actually had many different types of parts, when we used foreign keys to make that affirmation, it helps us to write better, more efficient queries that are actually able to be more helpful to us. Otherwise, our queries would just say, this supplier finds, this supplier one part. It's like it might if we didn't have foreign keys in here, actually we may not even be able to find out this kind of information at all. You'd have to write some, I guess, a different kind of more repetitive code, I guess, that would kind of, for each part, it would find the supplier's name and then somehow connect them together. But if you use this kind of code in SQL, then one query can tell you really all the parts from each of the suppliers. Anyway, each part, though, has one line, or each part has one line item, but each part has several different line items. One line item has one part. You can see by these markings on these little lines that connect these boxes at the bottom of the slides here, that it's not a one-to-one relationship. You may have many different line items for each one order. In this diagram here, one or two slashes going up and down really means that there's one item, and then if you have that kind of like greater than or less than, that's kind of showing you that there's multiple things in that table for the one thing in the other table. Anyway, DB browser was an important tool. I liked this because we were able to, as we were writing SQL code. In fact, I use this every now and then when I'm writing code. If I'm working with a really long query where I have a lot of different attributes to keep track of, or if I'm working with foreign keys, I want to be able to see how things come together. If I'm working with one-to-many or many-to-one, then I would use something like DB browser because I can see, as I'm typing my code on the bottom, or wherever I'm typing my code, I can see what my table looks like. So I'm reminded what my attributes look like. So I know what the attributes are, and I can kind of get an idea about how they're connected, and that helps me to actually write queries which are actually more meaningful to me rather than just queries that don't mean anything. Yeah, but you can use this if you like. It's free software. It's even open source software, and you can pick it up and actually see how the source code works if you're interested, and then you can reapply it to your own thing. We talked about joins, where we're actually taking information from two different tables and somehow connecting them together into one giant big table. That's called a join. And again, all of this stuff that I'm talking about now is about the relationships. So we made a huge fuss about the relationships in this class so that you could run these queries, so that you could run joins, so that you could do all of these things. But really, though, the joins that we worked with was just this code down here. Nothing too crazy. And here's some joins. When you're looking at joins in the sense of like a Venn diagram, it always helps, I think, to see these things graphically. But here we are. That's just your Venn diagram of how the joins work. So in the join, and I'm looking at the A and B join on the left-hand side, you have one table which is leading and the other table which is following. And so in this particular join, one thing we discussed was called the left join, where, for instance, the table on the left was actually being checked, and if you found any information that was in table B, which you already found in table A, then you are to list that information in some new table that you're working with or some view that you're working with. On the other hand, on the right-hand side, you're using table B as the reference table. So you're looking at table B, and if you find any information in table A, which is also found in table B, then you are to include that information as an output. That information is an output of your join in that particular case. Anyway, I think you get the idea. Then we talked about like using Python with SQL. These were the basic steps in any Python program or any program at all for connecting to a database. And so, for instance, you have to define some kind of you define your query as a string, which we did in MongoDB and in SQL. The same thing. We basically created a query as a string. We connected to our database, and then we used the library that came with our with Python the libraries that manage the database to actually run the query. And by running the query, we were just sending the string that we had defined to the library, and then the library did some work for us, which we didn't see. It all happens behind the scenes, and you don't really know what exactly happens. But what you do is you get a result, and then you have to analyze that result. In some ways, in our class here, the analysis that we had to do was to really parse the results and then to print it out, and that was really all there was. But then once we had that result, we were able to see what was in the database. We also were able to, there's also ways of, if you're not analyzing a result, you can also commit changes. That means, for instance, the query may not be a query, it may be more of changing data. And so once you have connected to the database and executed that change, you have to commit the change, and then you're done. And then at the end, you have to clean up, and that really just means closing your database connection. Otherwise, the database connection remains, it just takes up memory. So you want to clean up and close the connection. But these are the basic steps. There's nothing more than that. It's just the basic steps that we use to connect to a database. And so you'd use this actually if you're working on a lot of databases are found on the internet. This is a picture talking about people logging into a World Wide Web. such a dated picture, but it's a server that's online, and the server is actually connecting to the database. And so the idea is that each person who's logging into this server is able to interact with the database, but they don't have to actually type in code. Rather, they just work with the Python program or the JavaScript program, or whatever the code is that they're working with on the server, and then that will run steps which are exactly like this to analyze or to get information out of the database. We also worked with Django to kind of drive this point home. Django is only one of many different systems where you can get databases to working on the cloud or online. But it's a very simple system. It works with Python. We were able to use our wizards and to create a database which was really working seemingly out of the box. All we had to do was just to modify these files here, and you have all the notes in your slides for how to modify these files. But you'll find that it's really not a big thing. It's just a lot of files to modify, but it's not difficult to modify these files. And so now you have the ability to create a very fancy online database system that people can log into and interact with, and they won't actually have to know any code at all in SQL, yet they can still work with the database. And so that's actually quite an exciting thing. Um, by the way, when there was I don't know if I mentioned this. I think I may have done it before, but one of my students actually was hired in on some Wall Street job because of skills in Django, and so his job was to go through data that came out of financial records, and to parse it and put it on some website that they were putting together, and it was actually quite nicely paying, as I understand. Anyway, I'll move on to that. It's a good skill to have, Django. But there are many, many other types of systems out there. There's Flask and some other systems that are very similar. And I think that if you have one, then it shows that you can learn any system. Then we switched gears a little bit in this class, and we began working with NoSQL. And NoSQL was kind of, these are these kinds of systems here where we work with Mongo, but they're basically systems where you don't have to have a defined schema in the same way that you have to have for SQL. It's just another way of recording information. This is more of an unstructured information. So as information comes in, or as data comes in from the internet, you don't have to know what it looks like before you can record it. Whereas you would in SQL, you'd have to know what the database looks like before you can actually start putting data into it. Whereas when we used MongoDB, we didn't need to know what the data looked like. We just needed to know that it was coming in, and then Mongo handled all the storage for us. It handled the schema for us. It was a schema-free system, and so remember we were working with collections like this. We just basically took the data in as it gave it to us, and we put it into some kind of an order that looked like this, and that was really all that was necessary to record data. Then also we worked with databases like visual databases, which I've mentioned before. I think Neo4j is actually a very exciting. They're all exciting databases. Don't get me wrong. I think that Neo4j is actually very exciting though, in that you're actually able to discover types of relationships which exist. You can determine relationships that exist in your data. And if you're working in a science type of environment, like a scientific environment here, where you have data, you may not know actually how that data is connected. In fact, you may not have enough information from the data that you're connecting to build a database in any other system. Maybe you don't know how you can connect data in SQL. Maybe you just have to use time or some other arbitrary information to actually connect this information, but maybe that's not the best connection you could use. Whereas, for instance, if you put this database together in Neo4j, you may start noticing that your nodes are clumping in a specific way, which suggests a new relationship, which you had never considered before. And so when you're working visually, it does help you to make discoveries. And I think that Neo4j is a very simple system to allow us to make these visual discoveries of how the things are related. Now, you can actually still create your own relationships between your nodes, and in fact you have to create some kind of relationship between your nodes when you're actually putting the data in there. But for instance, in this particular relationship, you can find out whether some nodes are completely disconnected from other nodes. In other words, the node that we see on the right-hand side here, that free hanging node, really has nothing to do with the rest of the nodes in the database. Now, maybe that's an outlier, or maybe that's your discovery, but you wouldn't necessarily see that if you're working with tables, but you would see that if you're working with like an actual graphical display here. You can find the single nodes. So you can actually create kinds of relationships if you want, where, for instance, you can just basically put people who are, in this case, you have two different people here who are married. One person owns a car, and the other person drives that car. But the thing is, though, that when you have this data coming together, you might find, for instance, that you may find that people know each other through all kinds of means that you didn't suggest were actually that you didn't know that were present there before. This is really where Facebook comes in. I mean, I'm not pushing Facebook on you, but it does do a very good job of recommending friends to you that you may know. In fact, when you log into Facebook, it says, maybe you know so-and-so who's related to such and such. And you might think, oh yeah, I know such and such. And so maybe so-and-so is my next friend here. And the idea is that you may know this other person because you're in social circles with the first person. And that is a relationship that you can discover through a visual network. Anyway, it's the same idea with Neo4j. Now you can do the same kind of investigative reporting with Neo4j and find out how you know your friends and how your friends know each other if you were to put their data into a database. Who knows what you'll discover. So when I talk about, like, for instance, what has this class covered, I ask myself, actually, maybe the better question is like, what has this class not covered? I think that in terms of databases, we've discovered some really important pieces of theory. We've discussed many important types of softwares. But I think, though, that you now have the makings to be very fine system admins and to find careers in databases if that's what you choose to do. Now, I'm not telling you that you have to go and find careers in databases. But I think, though, that you should be very successful now in going into a database career if you wanted it, because you understand maybe the importance or the theory or the kind of the logistics, all of these things when you're putting together a database, and you understand more importantly like what it can do and what it cannot do. And I think that's probably the most important piece. If you know what it can do and you know what it cannot do, then you are able to kind of figure out better ways of using it. So in terms of like what has this class covered, well, actually ask yourself, what have we not covered? And so now I'm thinking that you should take all these things that you've learned in this class, and before you forget them, write them down on your resume and use that. And perhaps this will make your, maybe you'll be able to find a career in databases if you're interested in finding a career in databases. Not that I'm telling you what to do, but these are good skills and you've worked hard enough to get them. So go ahead, show the world, put them down on your resume, let everyone know. That really is it. That's the these are the ends of my slides here. These slides are all in your class docs. I forgot to tell you to pull them over, but they're all there. I wanted to spend the rest of the time here. We have like maybe 2 or 3 minutes. You should have received an email from the admin today with an RSEs, your evaluations. I'd like to just ask you to take this time now. I think we'll end class now, but to take this time and to kind of go through those, go back to that email if you haven't. Maybe if you haven't received it yet, then you will do today sometime. But it's basically just to go through and complete your evaluation of this course, and that's it. I think that on Wednesday, remember, I'll just log into class. I'll just be sitting here staring and looking around. I don't necessarily have anything planned, but if you have any questions, then please do come. We can discuss those questions, and then we can stick around for, after the hour and answer any questions that you may have of your projects. But if you don't have any questions, then I would advise you just to start working on your project, kind of put the pieces together, start working on your status update, which is coming up. The due date is actually coming up on Wednesday. You can also reach out to me on Slack or on email if you have any other questions. Alrighty then, I'm going to leave it there. I've had a great course with all of you. I've learned a lot from you, and it has been an honor and a privilege to have spent the time with you to go through and to have this course together. This is one of my favorite courses, and this is one of my favorite classes. Everybody, stay well. I'll see you on Wednesday, maybe. Otherwise, I'll see you. Who knows? I mean, I'm always here, but we don't have any more meetings. Just use this time to work on your project. Anyway, take everybody, stay well, mask up, look after yourselves, rest, and get your rest. Take care, everyone. Bye-bye.